Let's talk a little bit more about dividing polynomials. When you're dividing polynomials, there's a couple different methods that you can take. In this video, I'm going to take us through dividing these two polynomials, and I'm going to do it using both long division and synthetic division so that you can see kind of a compare and contrast between the two. So let me set up my long division. Inside my long division setup, I'm going to have the dividend, which is that first polynomial starting with x to the fourth. And then I need to make sure that from the highest down to the lowest exponent, I am not missing any. So I should have x to the fourth, x to the third, second, first, and my constant all represented. But I'm missing that x to the third term that should be right here in between x to the fourth and x squared. So when I'm writing this out, I'm actually going to put a placeholder of 0x cubed. I have 0 of them. They're not written because there are 0 of them. So now I'm just going to write the fact that there are 0 x to the thirds. And that placeholder just makes it easier when I go to add and subtract later. It's going to allow everything to line up nicely so that I don't have to work too hard to combine my like terms. Then I just keep writing, minus 14x squared. I'm missing the linear term in between x squared and my constant. So I'm also going to put a plus 0x there and then plus 100. Then my divisor is going to go outside, x minus 5. And I start by focusing on that leading term of my divisor and asking what do I multiply that by to get x to the fourth? I need to multiply by x to the third. Then I go ahead and multiply down and distribute to get x to the fourth minus 5x to the third. As usual with long division, we now subtract, but remember that we're subtracting everything here. So that negative gets distributed to both the x to the fourth and that negative 5x to the third, which makes it positive 5x to the third. And then we just combine like terms down. X to the fourth and negative x to the fourth, those cancel. 0 plus 5 give me positive 5x to the third. And then I bring down my next term and I keep going. The question now is, what do I multiply that leading term by x to get 5x to the third? Well, I need the 5 because my x doesn't have a coefficient of 5, so I'm going to multiply by a positive 5. And then I have an x, but I need x cubed, so I multiply by x squared. And then I take that 5x squared and I distribute down. Distributing to x, I get 5x to the third, just like we wanted. And then distributing to negative 5, I get negative 25x squared. We subtract, but we subtract everything, so I distribute that negative to the 5 and to the 25, and then I combine like terms. Cancel, I get positive 11x squared, and I bring down my 0. X times, I need a positive 11, and I need another x to get to x squared. Distributing down, I get 11x squared minus 55x. Subtracting everything, this becomes negative and positive. Cancel, I get 55x, bring down your 100. And then x times, I need just a 55. 55 distributed down gives me 55x minus 275. Distribute. Cancel. I get 375, and that's my remainder. And I know it's my remainder because the degree that we're at now, 375, is less than the degree of my divisor, x minus 5. So basically, there's nothing I can multiply this x by to end up with less x's. So that is my remainder, and I go ahead and just write it as the part that didn't divide. So plus 375 over the x minus 5. So that would be how we do this using long division. But let's go ahead and do it also using synthetic division. For synthetic division, I'm going to do a very similar setup, but I'm only going to list my coefficients. And it's basically going to strip all the extra details away from our polynomial and allow us just to focus on the coefficients. So my coefficients of the dividend are 1. And then remember that I have 0x to the third, so I need that 0. Then I have negative 14x squared. I have 0 x's, so I put a 0 as a placeholder there, and then a 100. Then when I look at my divisor, what I'm going to do is take the opposite of the constant here. And this is because my leading coefficient is 1, so be careful that your leading coefficient is 1, and I'm just going to take the opposite of that minus 5, and I'm going to put that outside to the left. I'm going to draw a bar here, and basically this is going to be the subtracting down step when we were doing our long division. So that's going to be all we're doing, is we're just subtracting down, subtracting down, subtracting down. We're not asking, what do I multiply by to get anything? That's all embedded within this. I start by dropping my 1 down, and then I multiply up. 5 times 1 is 5. And then because I took the opposite of my 5, we're not going to be subtracting, we're actually going to be adding here. So I'm going to be adding down, 0 plus 5 is 5, and then I multiply up to get 25. Then we add down, negative 14 and 25 give me 11, and then I multiply up to get 55. I add down to get 55, and I multiply up to get 275, add down to get 375. So you might recognize a lot of these numbers from when we were doing our long division. And that's because it's basically the same thing. Again, we just took away all those extra details of the x's and we're just focusing on the minimum required to get through the division. When you divide, we take our degree of our dividend and divide it by the degree of the denominator. So I had 4 x's, but I'm dividing by 1x. So I'm going to reduce that dividend by 1, and I'm going to have a degree of 3 in my quotient. So these are the coefficients starting with a degree of 3. So x to the third, I have a positive 5x squared, and I just keep reducing all the way down until I get to my constant. And then this 55 would be my constant, which means that this is the leftover that didn't divide. So that's going to be our remainder. So to write the remainder, I just add on that 375 over your divisor, which is x minus 5. So your final polynomial would be x to the third plus 5x squared plus 11x plus 55 plus 375 over x minus 5. So we got to the same place using 2 different methods. Hope that helped. Thanks for watching, and I will see you next time. Bye.